This video is going to go over horizontal and slant asymptotes. Notice I put here the reciprocal parent function 1 over x, and we're thinking horizontal asymptotes as end behavior. So when I'm looking at a graph, as x goes to positive and negative infinity, if your function ends up approaching some number, then we're going to call that a horizontal asymptote. For any rational function, p of x is a polynomial on the top, q of x is a polynomial on the bottom. Q of x is not 0 on our domain. If q of x is 0, it might be a removable discontinuity if the top and the bottom have the same factor, or it might be a vertical asymptote. But horizontal asymptotes are different. They're looking at end behavior. If the degree of the numerator is less than the degree of the denominator, then we say that will approach 0 as we go to positive and negative infinity for our x's. If the numerator is greater than the degree of the denominator, then we're going to have what's called a slant asymptote. And if the numerator is equal to the same degree as the denominator, then the horizontal asymptote is a ratio of the leading coefficients. Let's go ahead and look at this example right here. When I'm looking at a or g of x, I'm noticing that the leading coefficient of the numerator is 6x cubed, or the leading term of the numerator is 6x cubed, and the denominator is 2x cubed. Since the degrees are the same, I know that y equals 6 over 2, the ratio of the leading coefficients. Y equals 3 will be my horizontal asymptote. Let's look at B. On this one, I notice that my top term is x squared, my top leading term, and my bottom leading term is x. X squared is bigger than x to the power of 1, so I'm going to have what's called a slant asymptote. I'm going to divide my denominator into my numerator using long division. I get that h of x is the same as the function x minus 6 plus 13 over x plus 2. Now, as x gets really big, this part of h of x will get really small. However, the rest of the function is going to behave like this line. So we say y equals x minus 6 is the slant asymptote of this function. Let's look at one more example. Let's look at k of x here on part C. I notice that my leading term in the top is x squared. My leading term in the bottom is x cubed. 3 is bigger. I like to then say the denominator grows faster. And when that happens, my fraction grows smaller. Therefore, y equals 0 will be my horizontal asymptote because the degree of the denominator is larger than the degree of the numerator.